Okay, welcome to my channel. So today I'm going to start lecture 1 of this GATE 2019 chemistry papers, and I took selected questions which is concept based, and please keep and understand what is the question asking, and how I approach to solve these problems. So because approaching of the question is very important, how to approach the questions before you start. Okay, first you clearly read the proper question, then you can start. Okay, so okay, यदि आप सब्सक्राइब नहीं किए हैं मेरे चैनल को तो प्लीज़ सब्सक्राइब एंड लाइक करें और फ्रेंड के साथ शेयर करें, एंड if you have any doubts, so please write in comment section. I will try to reply you. Okay, so question first is given. This is question first. Question first is saying to find the CO stretching frequency of this given complex trigonal bipyramidal cis MCO whole thrice L2. L2 is ligand. So here find the CO stretching band in IR spectrum. So I am reading questions. What question says? Question is asking the question is asking okay, the numbers of CO stretching bands in IR spectrum of trigonal bipyramidal cis M, where M is metals, CO bracket CO whole thrice L2 is. So here the mainly asking the stretching band in IR stretching band of CO. So how to find the stretching bands? So first you draw the structures, means how the shape, how the structures of these molecules. So as I draw, this is there is mentioned cis molecules. Here is mentioned cis. So according to this I draw this structure. This is these two ligands. This is equatorial, this is axial. So these are two cis, and you can see also these are cis, and these two CO, one is up the plane, another is down the plane. So this is possible structures of this cis trigonal bipyramidals. So how to see the IR stretching bands, COS IR stretching band? So here the cis trans, so axial equatorial X isomers can see, and here the center of symmetry point group is there. Okay, CS point group is present, and only here the 3 carbon monoxide ligand is attaching to these metals, which is axial position, other two is equatorial position. So they will provide the they will give the stretching bands. Okay, so mostly here the 3 CO stretching band will present is present here. Okay, so hope you understand. So next question is question number 2. Questions is saying, consider the following phase diagram of CO2 at equilibrium, and we have to find the incorrect statement. Is here given some plot pressure versus temperatures, and as I draw in the boards, this structure is given to us, and here given some options A, B, C, D, and in their option written the statements. So I am reading first statement. At 200 kelvins, on increasing the pressure from 1 to 50 atmosphere atm, CO2 gas condensed to liquid. Is it possible? Is it correct or incorrect? So if you see at 200 Kelvin, when increase the pressure from 1 atmosphere to this 50 atmosphere, here your 50 atmosphere is here. So is it condense the liquid CO2 from gases? Is it condense CO2 gas to liquid? See, when increase the pressure like 1 to 50 atm, so if you see at 200 Kelvin, there is written to at 200 Kelvin, so your 200 Kelvin is like here. Like here your 200. If you go here, like say 200, this is your 200 Kelvin, and if you go there upside at around 50, so basically this region is solid region. But question statement is saying, when increase the pressure from 1 atmosphere to 50 at 200 Kelvin, the CO2 gas condensed to liquid. So is it possible? Is it not possible? So this statement is incorrect. Okay, this is solid, not liquid. So this statement is incorrect. And if you see next option, second option, it is not possible to obtain liquid CO2 from gaseous CO2 below 5.11 atm. So here is saying it is not possible to obtain liquid CO2 from gaseous CO2 below 5. Is it possible or not? If you see below 5.1 atm CO2, liquid CO2 from gases, if you say this below means 5.11. if you see below in 5.11, you will come this region. So this region, okay, this region means gaseous region. So you can get CO2 liquid in CO2 gas. Okay, you can get. So this option obtain liquid CO2 from gaseous below, it is not possible. So here is saying it is not possible. So we have to see the is it correct or not. So is it not possible to obtain liquid CO2 from gaseous CO2? Yeah, not possible, because if you see in above of 5.11 atm, you have in above problem you have liquid CO2, but down you don't have liquid CO2, so it is not possible in below the 5.11 atmosphere pressure. So you will get gaseous, not liquids. So it is here mentioned, it is not possible to obtain liquid CO2 from gaseous CO2 below this 5.1 atmosphere. So this option is correct. So this is not incorrect, but question is asking incorrect option. Be careful. So only first is incorrect. Now move to say C option. Both liquid and gas phase of CO2 coexist at 298.15 Kelvin and 67 atmosphere. So both liquid and gas phase of CO2 coexist at 298 at 67 atmospheric pressure. This is liquid and this is gas citizen. So both are coexist at this temperature. Exist, यहाँ पे कोई डाउट तो है नहीं, एग्जिस्ट करेगा ना, राइट. सो ये ऑप्शन भी, सी ऑप्शन भी करेक्ट है. एंड नाउ सी द ऑप्शन डी. With increasing pressure, the melting point of solid CO2 increase. If we increase the pressure, is it melting points of solid CO2 increase? Yeah, exactly, it will increase. Okay, so best option according to the question is asking at equilibrium, incorrect statement. So incorrect statement will be first. Okay, hopefully you understood. So incorrect option will be first. What's the first option? Answer of this option is option first. So here at 200 Kelvin, and at 50 atm pressure, I am writing in short way, not and from 1 to 50 atm pressure, you will not get liquid CO2. Okay, CO2. So this is the incorrect option. Sorry, this is here saying CO2 condensed. Okay, so here CO2 will not condense. Okay, if you increase 1 to 50, here you can see, so atmosphere at 200 Kelvin, the gas CO2 gas condensed to liquid. So here is solid region, so it will not condense. So it will not condense to liquid. Okay, so this option is incorrect. So actually this is in option they are not written like this. So here I am clearly saying the option 1 is incorrect. Okay, actually you are seeing also the question, so you have also the option, so you can carefully read. Okay, so because I don't have much space, that's why I am not writing the statements. Okay, now question number 3. So third question is saying the delta zero value of this complex NiS2 of NiS2 whole 6 2 plus is delta value is given 8500 centimeter minus. The delta zero value of nickel Cl6 whole 4 minus and nickel ammonia NH3 whole 6 2 plus charge compared to this nickel water molecules, octahedral water molecules 2 plus charge are. So basically यहाँ पे delta zero value given है of this nickel वाटर कॉम्प्लेक्स मॉलिक्यूल्स का 8500 सेंटीमीटर इनवर्स, और हमको जो है कंपेयर करना डेल्टा वैल्यू ऑफ गिवन टू अदर कॉम्प्लेक्स विद रिस्पेक्ट टू निकिल. ओके, सो निकिल्स कॉम्प्लेक्स हैज़ गिवन डेल्टा वैल्यू, अदर टू कॉम्प्लेक्स को हमको कंपेयर करना विद दिस निकिल. सो हाउ टू कंपेयर? सो इफ यू सी all three complex nickel water complex and chlorine nickel and ammonia nickels. So here metal is same but ligand is changed in all three cases. So we have to judge the value of delta zero. How to judge? So because we know the relations, delta zero is depends on ligand field strength. So if the ligand's field strength is more, then obviously the delta value will be more. Okay, so here the ligand field strength for ammonia case is more than water, than chloride ion. So you can easily now compare. Okay, so here I am written the order, field strength order, then delta value also would be for this ammonia case will be more. Okay, so how to compare according to option? So if you compare for this delta value for this nickel chloride, okay, so for case nickel chloride, and for nickel chloride we compare this nickel water molecule water complex. So for because I have seen other chlorine cases a very lower delta value. Okay, fine. So I'm talking about this here the delta zero value for ammonia will be more than water, then chloride, and then the comparison of this complex with this complex water molecule will be lower delta value, and comparison of this ammonia molecule with this water molecule, for this comparison of ammonia with this is more. So you see option first option is higher and lower respectively. So comparison of this water complex with nickel is what I have decided, lower, but first option is given higher. Now see second option is given lower. Okay, this may be correct. Now see second complex nickel with ammonia. So because of ligand field strength of ammonia is higher than that of water, so delta zero value will be the higher. Okay, so second option will be the correct option, and other two option is not correct because C option is given higher in both complex ion and D option lower in both complex ion. So only option B will be the correct answer. Okay, आशा करते हैं कि आप लोग समझ गए होंगे. ओके, सो अब हम मूव करते हैं नेक्स्ट क्वेश्चन. सो नेक्स्ट क्वेश्चन फोर question is given to us. What is four question? Four question says given friendly isotherms. Okay, question is saying in a friendless isotherm linear relationship is obtained in a plot of, so this plot given option theta versus p pressure and ln theta versus ln p pressure, ln theta versus p and theta versus ln p pressures. Okay, so we have to see the linear in which option the linear relationship is obtained. Okay, by using these friendless isotherms. So as we know the friendless isotherm is theta is equal to k into p to the power n. P is pressure and is any integer number which is less than 1. And if you take I am moving according to the options. If you know this friendless isotherms, this value, then you can move according to option. So if you see option is given to us ln in terms of some option given without ln and some option given with ln. So I am also trying to take ln both side of this expression. You will get this ln theta and here is I used multiplication of ln. So ln a into p is when open this ln a into b, then you will get ln k plus n, because the power of p will come before of this ln. So n ln p. So simply you will get like y is equal to mx c types equation. So you can easily compare y. Here y is ln theta and m is slope m n and x is ln p. So if you plot this ln theta versus this ln p, will get a linear relation. Okay, we'll get a linear relation. So linear relation. So this is the option is ln theta versus ln p. So option will be the option C will be the option B will be the correct option. In option B is given ln theta versus ln p. So option will I have written in right side in top this ln theta proportional to ln p. So this holds the linear relationship, okay, between this surface coverage theta and partial pressure of the gas. So hopefully you guys समझ गए होंगे कि actually the question क्या पूछ रहा है. Okay, so this is the option of this question option is B. Okay, now we move to the question 5. So question 5 क्या कह रहा है? Question 5 is saying consider a two-state system at thermal equilibrium having energy 0 and 2 kb T into T, where kb is the Boltzmann's constant, is temperature, for which degenerates are 1 and 2 respectively. As I mentioned, according to the question, I have considered two energy levels, E1, E0 and E1. If you question number 5, and energy is given for E0 is 0 and for E1 is 2 kb T, and degeneracy is given for this energy level is 1 and for this energy level is 2. As I told, the kb is the Boltzmann constants, and this system is going at thermal equilibrium. Okay, and we have to also know this value beta is equal to 1 upon kbt. So here question is asking find the value of partition function at absolute temperature T. So question is asking the value of partition function of at same absolute temperature T is what will be the partition function. So as I know the formula, this partition function Q is equal to summation of gi e to the power minus b ei. Okay, epsilon I. Okay, so where this summation start from I is equal to 0 to I. Okay, so because here in question we have given two energy levels, so we consider ground state energy E0 and first excited state E1 is energy, so only we have two energy state. So similarly we consider only two terms, okay, G0 and G1. So if you open summations, you will get G0 when apply I0 is equal to 0, I is equal to 0 to G0 e to the power minus beta epsilon 0 plus, because summation is open in plus term, so in plus, so we have put it here plus G1 second term g1 e to the power minus beta epsilon 1. So simply here g0 is given to us, degeneracy of this zero energy level 1, so I put here g0 value is 1. Okay, so basically so here g0 1 g1 is equal to 2. So these are the degeneration energy level of E0 and this energy levels of E1. Okay, so simply you put all these values in that expression, you will get your choice, means choice of, not choice, you will get the answer. So simply solve, and as I mentioned, beta is equal to 1 upon kBt. So you put here in place of beta kBt, and here epsilon 0 is 0 for this energy level, so energy value is 0, ground state is 0, so I put it here 0. So if you multiply 0 with any other numbers, you will get whole 0, so e to the power 0 will be the 1, so these whole terms will become 1. And if you see this, similarly I put it here, beta is equal to 1 upon kBt into 2 kBt is the E1 energy state values. So this term kBt will cancel out, and you will get only 2 e to the power minus 2. Okay, so now you will get this final expression, final value, q is equal to 1 plus 2 upon e square. So as we know, the exponential e's value is 2.718, so whole square of this value and square of this value will get this 7.38, and if you divide 2 by 7.38 you will get 0.706, and adding this value plus this you will get this q is equal to 1.2706 of this partition function at absolute temperature. So this is the partition function value of at absolute temperature. Okay, right. So now move to the next question, question number 6. So question number 6 is saying six is saying gas phase bond length and dipole moments of a compound, mx compound, is given to us, where the bond length is given is 3 angstrom and dipole moment is given 10.8 dBi respectively. So and asking the ionic character in the gas phase mx is, what is the ionic character, what will be the ionic character in gas phase of mx compounds. So here given to us gas phase bond length of this mx compound is 3 angstrom and dipole moment of this mx compound is 10.8 dBi. Okay, so here we have to find the ionic character in gas phase of this mx compound. So simply since we know the percentage ionic characters is equal to mu observed dipole moment and mu calculated dipole moment into 100, so we have to find ionic character in gas phase of this mx compound. So we have to see because here this is given dipole moment. Okay, observe the dipole moments are given, and we have to calculate dipole moment. So as we apply the formula mu calculated dipole moment q into d, where q is the charge of electrons. So here I put the charge 1.6 into 10 to the power minus 19, and d is the distance gas phase bond length 3 angstrom to 3 in meter. Angstrom, if you remove angstrom in meter, then you will put 10 to the power minus 10, and finally we will get mu calculated 4.8 into 10 to the power minus 29 coulomb into meter. Okay, this is your calculated value. Now as I written in formula, percentage of ionic character is equal to mu observed upon mu calculated into 100. So mu observed is given to us in question 10.8 by, so if you convert coulomb into meter, so you multiply by this value 3.336 into 10 to the power minus 30, and then you will get the coulomb into meter. Okay, so you have mu observed value and calculated, you put simply, you will get the percentage of ionic characters in gas phase of these MX compounds. Okay, so it's a little bit conceptually, but question as little bit easy. Okay, so this way you can approach and you will get the answer. Okay, now we move to the next question. So next question is, okay, first I will erase this, then I will start next question. Next 6 question I have done. Okay, so this GATE exam is also coming very near to us, so please do hard work and be positive, and don't keep in your mind negative things, so because these negative things will also affect the question, means that affect in exams, and also affect your last moment preparation. Okay, right? So question number 7. Question number 7 is saying the entropy change for melting of X mole of ice at 273 Kelvin and 1 atmospheric pressures is 28.80 calorie per Kelvin inverse. The value of X is, okay, and here the heat of fusion is given to us is 80 calorie per gram inverse, per gram or gram inverse. Okay, so here the given to us temperature 270 Kelvin, pressure is given, and delta as entropy is given. Okay, right? So question number 7. So entropy is given to us entropy is given to us delta is 28.80 Kelvin inverse, and heat of fusion and temperature is given 273 Kelvin, and pressure is given 1 atm. Okay. Delta H fusion, you can write fusion F is given SC calorie per gram. Okay, so we have to find X. What will be the how much moles of X, moles of ice melt. Okay, so here how much amount of your ice this melts, so that X value you have to find. Okay, so things how to approach these types of question. The entropy change for this melting of X moles of ice. So entropy is given of melting of this X moles of ice 28.80 calorie Kelvin inverse. Okay, and heat of fusion is given 80 calorie gram inverse, and temperature is given 273 Kelvin, pressure is given. The value of X is what? Okay, the value of X is what? As we know the entropy in terms of temperature. Okay, so here you have to find the how much amount X is melting. Okay, so as we know the this value is given to us. Okay, as we know the entropy delta S is equal to delta H upon T. Okay, so delta S fusion is given 80 calorie per gram, and temperature is 273 Kelvin. Okay, so if you divide this you will get 2.93 calorie Kelvin inverse gram inverse. Okay, this much we will get entropy. Okay, and already entropy is given through the meltings. Okay, and this means entropy will you have calculated, so you can easily compare. Because how to compare, since 0.293 entropy, this value in 0.293 entropy change, you will get 1 gram of ice melts. Then what will be the, according to our question, 28 Kelvin Kelvin inverse, then how much you will get ice melts? So 1 upon 1 into 80 upon 0.293. So absolutely you calculate, you will get the x value from here. And divide this value by 18, because of here we have to find the in gram how much amount. So weight of water in gram we have to so multiply by 18 gram per moles. Okay, gram per moles. So you will get moles, because here you will get in gram, this value you will get gram, so gram you will get, and then x value you will get in moles. Okay, moles. So this will be the answer of these questions. Okay, तो प्लीजली आप लोग समझ गए होंगे. ओके, फाइन. So now we move to the next question. So next question is basically you will get the x value after divided this. Here you will get 98.28, and when they divide this, then you will get 5.46 moles. Okay, so now next question is question number 7. Now I use black. Next question is okay, question number 8, and question number 8, because I am using different current, so you can easily separate out. This question is finished from this blue region, and this again new question is started from red colors. Okay, so question 8 is asking what the question is saying. Question is saying the rate of the following redox reaction, some redox reaction is given, is slowed when x is the what will be the x value, what will be the x value when the reaction will be slow down. Okay, so this is a big reactions. Is it possible to write the question? Okay, let's try. So reaction is given, redox reaction is redox reaction. Okay, the redox reaction is given to us. CO cobalt 3 oxidation state, and this ammonia col 5x, oxidation is 2 plus 2 plus 3 plus 2 plus. Okay, now react with chromium. Now react with chromium second oxidation state, water, here the value of oxidation 2 plus, and form the here cobalt, second oxidation state. Okay, right here ammonia 5H2O. okay, this is product of this redox reaction, plus one more product will form chromium, third oxidation state, and water X3 plus 2 plus. Okay, so this is redox reaction is given to us. Okay, it's big reaction. So here asking the slowest the rate of given redox reaction. So find the slowest rate. The rate of following redox reaction is slowest. So find the slowest rate of given redox reaction by choosing option A. Option A. So basically here we see the X value. X is given to the options. X may be the water, and B, X will be the maybe the ammonia, and C, X will be the chloride, and D, X will be the N3 minus. So you have to pick which X is better for this. Slow down the rate of this redox reaction. Okay, so you see, be careful. Here CO is 3 oxidation state attaching with ammonia, but here chromium is 2 oxidation state. So from this reaction we can easily say from this is redox, absolutely redox reaction, because CO is here your 3 oxidation state, but here CO is 2 oxidation, so here is reduction. And if see chromium is 2 oxidation state, and here is chromium is 3 oxidation, so this is oxidation. So as we know that in redox reaction, oxidation and reduction parallelly happen. That's why we call the redox reaction. Okay, that one is the other things, but what will be the X values for better X value for this redox reaction? So first, if you see here, this is ammonia 5 and X, this is chromium 6 water molecules. Okay, so this question here, if we see here, so here actually, and we have to select. If you see here, this is cobalt 2 oxidation state, and here ammonia 5 ligands, X we have to choose from this option, and here water molecule 6 water molecule, and so this is second reactants of this chromium second 6 water molecules to plus oxidation stage. This is complete, but here only missing one ligands of this X. So if you see is it suitable for this, is it suitable water molecule for here? See, if we put here water molecule, so this water molecules is comes here, no doubt, but oxidation state will change, okay, reduction will happen. But if you see here, this water molecules is replacing what? If we putting here water, then here again water, okay, so this become 6 molecule of water, but here the not possible vocal because two ligands will be different, and here water again become 6, okay. If you put here water, so here one water is coming here, so this water coming from this water, okay, water molecules, because here already 6 moles of water molecule ligand. So if you put here water and this replace here water, okay, fine, no problem, this reduce, okay. And if put again here water, because I am choosing here water, then this will again 6 moles of 6 ligands of water of this chromium 3 plus, and which is not possible because this 6 water and this one more ligands become 7 water, because but it is not possible because only we have in reactant 6 ligands of water, so this option is not correct, okay. Now move to the second option. If we choose ammonia, so ammonia, let's put here ammonia, okay, fine, ammonia, and here if you see here there is no problem, okay, only problem is here, is it fit ammonia for this complex? Right, fit, because if you put here ammonia, so counts, so 5 here, 1 ammonia here 6, and this become also 6, so no interfering to other ligand complex, okay, other ligand to the complex, so ammonia is fine. Chlorine is not possible, and this and 3 is not possible, so mainly the option B is correct option. So X will be the ammonia for this redox reaction, okay, fine. So hopefully you guys understood in this lectures 1 GATE 2019 chemistry papers, and in next video I will take some other challenging questions which have been asked, okay. So up to here enough. Actually I considered the lectures in this lectures 8 questions, so okay, बाय बाय. अगर आप सब्सक्राइब नहीं किए मेरे चैनल को, सो प्लीज़ सब्सक्राइब एंड लाइक the channels and click the bell icon so that you will get easily notification when I upload the video. Okay, good night, bye bye, thank you.